The Rankine cycle is fundamental to power generation and various industrial applications. In this video, we'll explore what the Rankine cycle is, its key applications, and methods to enhance its efficiency. The Rankine cycle is a thermodynamic cycle that converts heat into mechanical work. It consists of four main components: the boiler, turbine, condenser, and pump. Here's a simplified diagram showing the stages: isentropic expansion, turbine; isobaric heat rejection, condenser; isentropic compression, pump; and isobaric heat addition, boiler. In the boiler, water is heated to create steam. This steam expands through the turbine to generate work, then it's condensed back to water in the condenser, and finally, the pump returns the water to the boiler. The Rankine cycle is widely used in various power plants, including coal-fired, natural gas, nuclear, and solar thermal plants. It plays a crucial role in converting heat energy into electrical power. In marine propulsion, the Rankine cycle powers marine engines, helping large ships navigate the seas. Additionally, industries like chemical manufacturing and food processing use the Rankine cycle in waste heat recovery systems to improve energy efficiency. There are several methods to increase the efficiency of the Rankine cycle: increase boiler pressure, superheating the steam, regenerative feed heating, use of reheat cycles, and improving condenser performance. To sum up, the Rankine cycle is vital for power generation and industrial processes. By understanding its applications and exploring ways to improve efficiency, we can optimize energy use and reduce costs. Thank you for watching. For more insights into thermodynamic cycles and their applications, please subscribe, like, and comment.